complex numbers. Here we are going to look at forms of complex numbers. In our previous video on complex numbers, the first episode, we explained the concept of complex numbers, and in this video now we are going to look at different forms a complex number can be expressed. Now we have different forms of complex numbers, but we are going to look at the three main forms of complex numbers. Three main forms of complex numbers. Number one, we have the general form, which can also be called rectangular form. This particular general form or rectangular form is given as z equal to a plus ib, which in some textbooks they may say that it is x plus iy. They are all the same thing. They are all letters. So x and a are the same, b and y are the same, just to show that this is the real part, while this serves as the imaginary part. So whenever we have z equal to something like 3 plus 2i, that is complex number in general form, or you say complex number in rectangular form. Now the second form of a complex number is what we call the polar form of a complex number. Now this polar form is given as z equal to r bracket cos theta plus I sin theta. Now let's look at how this was obtained. Since we have the general form of a complex number to be z equal to a plus ib, if we want to get the polar form, we have that our a is given as r cos theta. This is an expression for a. So we have that our b is given as r sin theta, because this serves as the real part, while this serves as the imaginary part. When we substitute this for a and this for b, we're going to have that z is equal to r cos theta plus I, this I now, then b will now be r sin theta. Now, since r is here and also at this point, we can factorize to get r to the outside. We have that z is equal to the common factor here and here is r. We bring it out, then bracket. When this r divides this, it will cancel out this. So we're going to have cos theta plus I. This r will divide this, and we're going to have sin theta. So from the general form of a complex number or rectangular form, you can get the polar form of a complex number. So when a complex number is not written or expressed in this form, it can also be expressed in this form. They are the same. Once you know that a is equivalent to this and b is also equal to this. So this particular form now, using the r and theta, which are not in this general form, we say that this particular form is the polar form. Now the r here is known as the modulus of the complex number z, while the theta here is known as the argument of z. Now when we solve to get our r and our theta, we can now substitute into this, and we now have r cos theta plus I sin theta. So when we get r and theta, we can convert our complex number from rectangular form to the polar form. Now in the third form of complex number, we have that z is equal to, which is that third part or third form is called Euler or exponential form. Exponential or Euler form. This is the third type or third form of a complex number. Now, in this particular exponential form, we are going to make use of exponential function in that particular complex number. That means the Euler form is going to give us z equal to r exponential I theta. Now, this theta is the same argument that we know, argument of z, while the r we have here is known as the modulus of z. So, since we have these three forms, we can be asked to convert a complex number from one form to another. So complex numbers can be converted from one form to another form. That means a complex number in rectangular form can be converted to a complex number in polar form or in Euler form. So in our next video, we are going to see how we can do these conversions. See you in the next class.